Hey guys, in this video we're going to talk about how to transform a parent function, how to change and how to make it go through transformations. Alright, let's get started. So here we have a general equation, right? We have a general function. Our function, f of x, will be affected by a c inside the parentheses, an a in front of the function, and a d on the very back. Okay? Our goal is to identify these three different variables and what they do to the function to see how it changes. Now, you might also see it as a, h, and k, right? A, c, and d, a, h, and k. It doesn't really matter what variables you see it as long as you know that the behavior in front of it, inside the parentheses, and in the back, what does it do to each function and how does it behave? So let's get started. Let's talk about a. The a value in front of the function is going to affect the direction of the function. Is it pointing up or is it pointing down? If it's positive, it should be pointing up. So positive function, the graph will be pointing upward, and I'll use a parabola as a scenario, or you know what, let's just keep it general. It's pointing up. If it's negative, it's pointing down. It's being reflected. Now this could be a quadratic, so the u would be pointing up, or the u would be reflected pointing down. Now, if a is greater than 1, what will end up happening, let's see, I'll write it here. If a is greater than 1, let's say that the number is 10 or 15 or anything bigger than 1 really. It could be a decimal or a whole number. As long as it's bigger than 1, this function is going to get skinnier. It's going to get stretched. It's going to get narrow. So in a parabola sense, right, you would have like a u that would be very, very narrow, like this. Okay, so the word here that we're looking for is a stretch. This is a vertical stretch, or you can say the word narrow. If we're looking at the other scenario where a is between 0 and 1, let's say that we're dealing with a small number like 1/2 or 1/3 or 0.79 or something between 0 and 1. Now we're going to talk about, if we're looking at a parabola, we're looking at something that's wide. Right? Here we're talking about a compression. Or wide. Now I'm using here as an example a parabola because you can see how narrow it is or how wide it gets. Right? But it could be any function that we're talking about. The function is going to get narrowed, stretched, going to get closer to each other, or it's going to get wider, further apart from each other. That is the effect of A. Now let's talk about the effects of C. C will always, most of the time, will be inside of a parentheses. Right? Most of the time, C will be inside the parentheses or attached to the X really close to it. So what C will do is actually behaves as an opposite behavior. Think of inside here as opposite. Okay, so if it says x minus c, it's actually going to move to the right. It moves to the right side. And if it says x plus c, right, the opposite behavior of plus c would be moving to the left. So this function is going to shift to the left or to the right, depending on the symbol or the sign of what's inside the parentheses. So if it says x plus 5, it's going to move 5 to the left. If it says x minus 10, it's going to move 10 to the right. Always think opposite inside this parentheses. Lastly, we have the letter d, which is our last variable that we're going to be affecting. The d variable is going to move the function up or down. So if d is, and this one's actually as straightforward as possible. If d is positive, the function is going to move up. If d is negative, the function is going to go down. And that's all it is. I mean, a great way to think about that is take anything, take any function, take your age, take anything that you know, and add a number to it. Right? Take your age, your mom's age, your dad's age, your dog's age, anyone's age, add a number to it, the number goes up. By the same token, if you subtract a number, your numbers are going to go down. Okay? Now, if you can remember A, C, and D and what it does to the function, you should be set. This is exactly how the function behaves. Let me move this to the side a little bit. Here we go. For any different function. Now, as I said earlier, you might also see this as a f x minus h plus k. I know there's different variables, but it's the same thing. A is the number in the front. H is inside the parentheses. And k is on the outside. So it doesn't really matter what variables you're using. Just think, is it in front? Is it being multiplied in the front? Is it inside the parentheses? Or is it on the outside? And you can change the letters to whatever you have. It'll still have that behavior for the A. It'll still have that behavior for the C or the H. And it'll still have the behavior for the D or the K. Let's look at an example. Here we have 4 different examples of 4 different functions. We have the absolute value function because of the absolute value lines. We have a quadratic function because it's squared. We have an exponential function because it's e to the x. And we have a cube root function. Notice how all of them will have an a in the front of 1/2. All of them will have a x plus 4 inside. Now these behave sort of as parentheses. Inside the square root, it's sort of together, it's already connected, so they're all x plus 4s. And they're all going to have the minus 5 in the back. So what does this mean? Well, the first thing that I would look at is the 1/2. The 1/2 in this problem, let's use a color that we can all see. Let's highlight this a little bit. The 1/2 is positive. So what can I tell about the 1/2 that's positive? Well, this shape, whatever it is, whether it is a parabola, a V, an exponential, or a cube root, this is going to be pointing upward because it's positive 1/2. Now, because it's also a number between 0 and 1, this is going to be wider. This is going to be a compression. It's going to make the function wider. So if it's a V, the V is going to be wide. If it's a U, the U is going to be wide. A lot wider. So it's pointing up and it's wide. The next number here in the middle is the x plus 4. Remember, inside the parentheses, when the x is close to that, it's always the opposite. So if it's positive 4, it's going to move to the left 4 units. And let's highlight this in black. Sure, why not? So this x plus 4 will move the function 4 units to the left, right? The opposite behavior of what we're looking at the symbol. So if it's positive 4 inside, think to the left. If it were minus 4, it would have been to the other direction, to the right. And lastly, we have the minus 5 at the very back. The minus 5, let's do this in a different color. Sure, let's do blue, why not? So at the back, right, this just changes the direction if it's going up or if it's going down. So the minus 5 means that the function is going to move down 5 units. That's what it's saying. Okay, so this V is going to go down. The U is just going to move down 5 units. The exponential function, it's going to go down 5 units. And the cubic function, it's going to go down 5 units. So it doesn't matter what your shape looks like, whether it's an absolute value, a quadratic exponential, or a cube root, it's going to take the function where it's at the origin and bring it down. The U is going to go down below the x-axis. This is going to move down, this is going to move down. I hope that helps. Please let me know if you guys need anything. We'll do more examples as we move on, but hopefully this gives you an overview of what A, H, and K, or A, C, and D does to a function. And if you can identify it from the equation, you can identify it from the graph. And if you can see the graph and how it's changing, we should be able to also identify what the function is doing. Hope you guys are having a great day, and as always, I'll calculate later.